Today I'm going to show you how using DuckDB together with Wasm can enable you to run a full SQL database in the browser. I'm just going to show you what that looks like using the example in the documentation. So we'll do create table. Now if we run show tables, you can see we've got a table T1. Select all from table T1 shows us the result of that query. This is entirely running inside my browser. So to make our website, all we're going to need is 3 files: a HTML file, a CSS file, and a JavaScript file. First, we're just going to add some boilerplate to our HTML. Add the title, Vanilla Duck. Next, let's start filling out the body of the homepage. We want to just put heading on the homepage. Again, we're just going to put Vanilla Duck, and I'm going to add an ice cream emoji and a duck emoji. Now we've done that, let's just see if we can load our web page. Just drag the file across. This looks like it's working. One thing I'd like us to be able to do is upload files and load them into our DuckDB database as tables. So the first thing I'm going to need is a way of uploading those files. So one way of doing that is adding an import tag to our HTML. Reload the page over here to see if that's appeared. Normally, an input tag by default will accept text. We want to import a file. You can just change the type here to file, save that, refresh the page. If you just go into choose file now, we can select the file that we want to upload. I'm just going to go into this datasets folder, and you can see in here that this could accept a JSON file. This dog data file over here, if you look, this is actually a CSV, and there's also 2 Parquet files. These are all formats that could contain data that we would like to upload to a table. Now, a text file could contain data that we want to upload to a table in our DuckDB database. However, for this example, this is a file type I'd like to exclude. I'm going to accept a CSV, a Parquet, and a JSON file. Refresh the page. If you go to upload a file, you can see in our datasets folder that the text file is grayed out, and all that is allowed is JSON, CSV, or Parquet files. So the next thing we need to be able to do is create a table from our chosen file. We need a button to action creating the table, and we also need an input box to be able to name the table. This time the input is going to be of type text. The placeholder is going to say enter table name. We also need a create table button. Refresh our page. Now you can see we've got a way of choosing the file, we've got a way of entering the table name, and we've got a way of creating the table. The next thing I would like to add is a table which displays all of the tables we've created in our DuckDB database. To do this, we're going to add another HTML tag called table. Once we've added the table, if we save and refresh, you won't notice any difference, and that's because we haven't added any columns or rows to the table. We're going to save that for later because we're going to do that dynamically. So I'm going to put another header, this time slightly smaller. I'm going to use H2. Underneath that, I'm just going to add somewhere for me to write the query. Now the problem with an input box is all of your text has to be on one line. So this isn't going to be suitable for a SQL query. I'm going to change the input box to a text area instead. For text area, we can specify the number of rows, 10. I'm going to give it the placeholder write SQL query here. As you can see, this is much better. The next thing we're going to need is a button to run our query. I'm just going to add another button. Underneath that button, we're just going to add another header. And this is just going to display the query that we ran. And then we're going to just add a div element, which will show our last ran query. The last subheading we're going to add is results. Now underneath here, we're going to return the result of our query. Now that's either going to be an error, and for that, I'm just going to put a div, or a table if there's nothing wrong with our query. All of the HTML elements we need for our web page are in place. However, none of them do anything yet because we haven't told them what to do using JavaScript. Next thing we're going to add is a scripts.js file. The main thing we're going to use JavaScript for during this project is to import and interact with the DuckDB Wasm binary. So to do that, we need to just write import all as DuckDB from, paste in this address. This address will be on the GitHub page for the project, which will be included in the notes. Declare our DB variable, which will represent our database. Now we need to write an asynchronous function that initializes the DuckDB database. To do that, we're just going to write async function init DuckDB. Within the curly braces, we're just going to try, and we'll add the error now because it's just going to be a generic error. Add a console error, initializing DuckDB Wasm, add on to the end the actual error itself, and let's just put a space there. Okay, so the first thing we need to do is get all of the different bundles that we might need to be able to create DuckDB in our browser. So to do that, we just create a constant JS_deliver underscore bundles, and we're going to assign to that DuckDB.get JS_deliver bundle. The next thing we're going to do is find the actual bundle that we need for our particular environment. So to do that, we do constant bundle await DuckDB.select bundle, and then we just pass to select bundle our bundles from above. To make use of our bundle, we need to run the main worker script that comes with DuckDB Wasm. Now, to be able to do that, we're going to have to create a temporary place for this to run. So I'm just going to use JavaScript to do that, and I'm just going to call this the worker URL. I'm just going to create an object URL here, and within that object URL, I'm going to create a new blob, and within that blob, I'm just going to store the script that I would like to run from there. So this script is just going to be import script, and then I'm just going to put the reference to the main worker script in here. So that can be found at this location. I just need to specify that this is JavaScript. Don't forget the semicolon at the end of here, and also don't forget to specify that this is the type. Now I'm going to use this location to create a new worker. So I'm just going to pass to the worker class the worker URL. I'm also going to create a logger using DuckDB, and don't forget to put new before the worker, new before the logger, DuckDB.console logger. Next, we need to define how we're going to initialize our database. So this is new DuckDB.async DuckDB. We're just going to pass this the logger and the worker. And then finally, we're going to run the instantiate method on that. And we're just going to pass to that from the bundle the main module and also the pthread worker. Now don't forget, we've also still got this temporary storage that we were using to run the main worker script from. So we just need to revoke that storage before we finish. And finally, just a console log to tell ourselves that this initialized successfully. The last thing we need to do is just add an event listener to our page so that this initialize DuckDB runs every time we refresh the page. When that happens, we want to run initialize DuckDB. If we just go to the inspect in our browser and go to the console and refresh the page, we'll notice that nothing happens in the console. And that's because if we go back to index.html, we haven't imported our JavaScript. Just under the title, if we just put a script tag like so, we're just going to say that this is scripts.js and specify the type of this script as module. Save this and hit refresh. You'll notice that cross-origin requests are only supported for protocol schemes, HTTP, data, and so on. So to get around this problem, what we're going to do is we're going to use Python to just run a local HTTP server. So to do that, we just write Python module http.server. And as you can see, this server is running on port 8000. So now I'm just going to go to localhost 8000. So now if I just go to inspect and hit refresh, you'll notice we still get an error. And that's because I've made a typo. So if I just go back to the script now, and here it says console logger, so that's here, and that's meant to be console logger. We have another typo here, and that's because it's capital D, capital B on async DuckDB, so I just need to change that. We've got another typo, and that's import script should be import scripts. Refresh the page, no errors, and also we've got DuckDB Wasm initialized successfully. Despite that, none of our components here actually do anything. Create table doesn't do anything yet, and neither does run query. We need to write some JavaScript that allows us to create a table from an uploaded file. So let's start by defining the function upload table. We're just going to put this in a try, and we're going to catch this with a generic error message. So let's do a console error again. Let's just say error processing file or querying data, and then like before, also show the error itself. So the first thing we need to do is get the input object from our HTML. Now, to be able to do that in JavaScript, we need to say that our file input object is equal to an element in the document. So to do that, we do document.get element by ID. However, to be able to do this, our element needs an ID. And if we go back to the HTML, our input element, which is the file one at the top here, this doesn't have an ID. We're just going to call this file input. So now if we go back to our JavaScript, we can get element by ID file input. The next thing we're going to do is assign the file itself to a variable. Now to do that, we're going to use a conditional ternary operator in JavaScript. And that's just in case the file input doesn't have any files to begin with. So the first thing we do is we check, does the file input have any files? So we access the files of file input and check if they exist or not. If they do exist, then we want to take the first value. And if no files exist, then we assign null to the file constant. The next thing we do is act on whether or not a file existed. So if no file exists, then we would like to alert the user, please select a file first. That will return and therefore end our function. And if not, we can continue. Now to create a table in DuckDB, we need a table name, and we want to get that from this text input over here. So just like the file input element, we also need to assign the table name input element to a constant in our JavaScript. Now to do that, just like before, we're going to go to document get element by ID, and this time we're going to say that the ID is table name input. But just like before, we haven't actually given that element an ID. So we need to remember to go back to our HTML. So we write ID equals table name input. Now we've got hold of our table name input in the JavaScript, we can take that table name input and extract its value and assign it to another constant called table name. And to do that, we say constant table name equals table name input dot value. We need to respond to a table name not being submitted. To do that, we just say if table name does not exist, then we would like to create an alert. And this time the alert will say, please enter a valid table name. We also need to add a return to end the function. Next, we need to convert our file to binary before we give it to DuckDB. To do that, we're going to convert our file and then assign it to a constant called array buffer. And to do that, we can use the array buffer method included in the JavaScript file API. Now that the file's in the right format, the next thing we have to do is to check that we actually have a database to give the table name in the file to. To do that, we just check if the DB element has anything assigned to it. And if the database doesn't exist, we raise an error. Now we've got everything that we need. Let's add some console logs so that we know where in the process we're up to. File loaded. And we're just going to dynamically pass the file name to this log. Next, we establish a connection to the database using db.connect. Then we add a console log to show that our database connection has been established. Next, we need to figure out what the file type is. We can do that by taking the file name and splitting the file name on the full stop. This will then create an array of strings separated by full stops. The final string in that array will be our file type. So we use pop to get at that final element. And if that exists, we then convert that to lowercase. And if that doesn't exist, we return an empty string. The next thing we need to do is determine if the file type is valid. So to do that, we create an array of valid file types. So our valid file types are CSV, Parquet, and JSON. And if this array includes the file type, then we would like to act on that as a valid file type. Else, we would like to return a message to the console, invalid file type, and show the type that has been passed. So now we just need to specify what happens if we have the correct file type. Next, we need to give our file in binary format an address in DuckDB's virtual file system. So to do that, we create a constant called virtual file name, and the virtual file name is just the address in DuckDB's virtual file system. So that will just be backticks / and then a JavaScript variable. And in the JavaScript variable, we'll pass the file name. And now we've created that address. The next thing we want to do is pass the binary version of the file, so the array buffer, to that virtual file name. So we await db.register file buffer. We take our virtual file name that we've just defined, and we give to that virtual file name a new uint8 array made from our array buffer. Next, we're going to write a query to read our file from DuckDB's virtual file system and write it as a table in DuckDB. Now, to do that, we'll need to use a specific function depending on the file type. Therefore, our query is going to have to be dynamic depending on the file type. So let's start off with an empty query that we can amend along the way. And now let's make some conditions based on our file type. So if our file type is equal to CSV, then we're going to do the following. Else, if our file type is equal to Parquet, then we're going to do the following. And else, if our file type is equal to JSON, then we're going to do something else. So if our file type is a CSV, we're going to overwrite the query with the query that you would write to create a table from a CSV file. So we're going to start with backticks, and in uppercase, we're just going to say create table, and then within single quotation marks, we're going to put in the table name, and that's just going to be the table name variable we've already defined as from. And now we're going to use the read CSV auto function to treat our file as a table. So within the read CSV auto function, we're just going to pass, using single quotation marks, another JavaScript variable, and this time we're going to pass the virtual file name. And then finally, we're just going to add the header flag. I'm just going to copy and paste that logic into the other two conditions, as the correct query for each case is going to be quite similar. So for Parquet, we're just going to change the function now to the read Parquet function, and we're just going to get rid of the header flag as we don't need that for Parquet. And we're just going to change the JSON query to the read JSON auto function, and we're also going to get rid of the header flag as we also do not need that for JSON. And then finally, we're just going to say await connection.query, which is how we run our query, and we're just going to pass our query variable to the query method. So now let's run our Python server again. Let's refresh the page. Let's go to the inspect, and we've got an error. This isn't very helpful because it says we're missing a close bracket after argument list, but if you go to line 55, you'll realize that actually we are missing a comma. This time, DuckDB Wasm initialized successfully, so that's all working great. But let's just see if we can create a table. So I'm going to choose a Parquet file. I'm going to choose the cars Parquet file, and I'm going to call this table cars, and I'm going to hit create table, and nothing's happened. If I go to the create table button, you'll notice that nothing's been set on here as an action to happen when we click the table. To do that, we just set onClick to the function that we've just created. And the function that we've just created is called upload table. Now, if I refresh the page, go back to here, choose the cars Parquet again, type in cars as the table name and hit create table, upload table is not defined. So the way to fix this is to add upload table to the event listener by setting window.upload table equal to the upload table function we've just created. Okay, so let's add our cars parquet file and enter the table name cars and hit create table. And we've got an error. Now this error says that the cars.parquet file is too small to be a parquet file. Now that suggests that the data contained within that file is missing or has been corrupted. Now if we just look over here at where we get the binary data from the file, there isn't an await here. Now that means that before this method array buffer has finished, the array buffer constant is being used to register the file buffer in the DuckDB virtual file system. So what we want to do is to prevent this from happening is add an await here, and that means that this method has to finish before array buffer is used later on to register itself in the DuckDB virtual file system. So now let's save that, refresh our web page, choose file, choose our cars parquet file again, give it the name cars and hit create table. And now we can see there's been no errors, which is great. However, what we don't have is a way to access that table. If I write the query select all from cars, nothing happens. And that's because this text box and this button don't have any functionality yet. Also, we said that we were going to add a table that displayed all of the registered tables. So we'd like to create a JavaScript function that updates the table that is the list of all registered tables in DuckDB. And we'd like that to rerun every time we add a new table to DuckDB. So we want to create a function that updates our list of registered tables. And we're going to run that at the end of every create table. So at the bottom of this function we've just created, we're just going to add another function called update table list. And that's a function which is to be defined by ourselves below. So let's start by creating our update table list function. And like all our other functions so far, we're just going to add a try and then catch any generic errors with a generic error message. Error processing file or querying data. We're just going to check here as well as above whether the database actually exists. So I'm just going to copy this from above, and that's just the first check we're going to do. And once we've checked that the database actually exists, we're just going to connect to the database and then add a console log to let us know that that's connected successfully. And let's also add an additional console log up here saying that update table list is now the function that's running. So we need to write a query that finds out all of the tables that are registered in DuckDB. In backticks, we're just going to write select table name as tables, and that's just so that in our HTML, the table name is actually displayed as tables because that's something that would be nicer to display in our web page. From information schema.tables, where table underscore schema equals main. Okay, so now we need to actually run the query, and we're going to assign the result of that to a variable called show tables, and that's just going to await the result of the query like so. Now DuckDB queries in JavaScript return a table that is in a format called Apache Arrow. Because show tables is an Apache Arrow table, we can use the Apache Arrow API to get access to the number of rows from that table like so. We're going to need the number of rows for creating our HTML table later on in the function. Something else that we'd like to do with our JavaScript that we haven't done yet is dynamically display and hide different elements on our page at different times. For example, we could hide the result element until there is actually a result to display so that we don't just have this result header on our page like so. And we're going to add a bit of logic in now for displaying and hiding different elements at different times. So there's two things that we need to get a hold of in our JavaScript first. So the first thing we need to do is get the tables div. So tables div equals document get element by ID, just as before. And this time the ID is going to be the tables div ID. However, that doesn't actually exist in our HTML. So we need to go back to our HTML and find the element that we'd like to call the tables div. Now, the tables div is actually going to be a div that goes around our table here. So we're just going to create that like so, and we're just going to give this the ID of tables div. And seeing as we've got two tables on here, just to make this a bit easier, we're going to give this table an ID of tables table, because this is going to be the table that displays all of the registered tables in DuckDB. And we're just going to give this table down here an ID of result table. Okay, now the next thing we want to do is get hold of another element, and that element is going to be the query entry div. And that again is going to be an element that we get using its ID. And the ID of this one, to be consistent, is going to be query entry div. The query entry div doesn't exist yet, but we're just going to put that div around these three elements here. And that div is going to have the ID query entry div. And now we've registered the elements that we need, we can act on the result of our query. The number of rows returned in our query is going to correspond to the number of tables registered in our DuckDB database. Therefore, we can add a console log here that will just say number of tables registered in database, followed by the row count we defined earlier. Now, if the row count is equal to 0, that means no tables are registered, which means much of our functionality should be hidden, because we won't be ready to do anything yet until we've registered our first table. So if the row count is equal to 0, we want to hide this div. We also want to prevent the user from trying to write queries when there aren't any tables. Therefore, we're also going to hide the query entry div, which we defined earlier. Now, remember, the query entry div is these three elements here. So it's the SQL query title, it's where you enter the query, and it's also the button to run the query. We'd like to hide this initially as well. So to do that, we set style to display none. Now, if we just refresh our page, the SQL query header, the text area to enter our query, and the button to run the query have all been hidden. But we also want to hide where the query is recorded and the result of that query, as they're not relevant to begin with either. So we're also going to wrap this section in its own div so that it's easier to organize. We're also going to give this a name so that we can get at it later. This is the query results div. And we're also going to set the initial style of this div to display none. Now, if we refresh our web page, the query results section is hidden as expected. There's a typo here, I'm just going to fix that. So this should actually say query entry div, and we're going to set the display of the query entry div to none. So if some tables do exist, we then need to make these two elements visible. So to do that, we take the tables div and set the style to block, and then we take the query entry div and set the style to block. Next, we want to take show tables, which remember is an arrow table, and turn that into a HTML table to display. As this is going to be useful logic elsewhere in our web page, we're going to create a function to do this. So let's refer to that function now, arrow to HTML table, and we're going to pass the arrow table that we're starting with, which is show tables, which is the result of our query. And we're also going to pass the HTML element where we would like to put the HTML table, which is the tables table. Then once we've done that, we close the connection because we don't need to be connected to our database anymore. And then we just do a console log explaining that the connection is now closed. So let's write our arrow to HTML table function. This takes an arrow table and a HTML table. Next, I'm going to check if the arrow table exists and that it isn't undefined. Now, if it doesn't exist, I'm just going to create a console log just to say that the arrow table object is invalid or null. And I'll return at this point to end the function. The next thing we're going to do is get the column headers. So we're going to assign that to a variable called table schema. To do this, we access the schema, and then in the schema we access the fields, and then we have to create a map because this is an array of fields. So for each field in fields, we would actually like to take the field name. Just so that I can sense check this, I'm going to console log the table schema as it's outputted. So column titles, and then let's add the table schema there. One thing I'm just going to change now is the name of this parameter. I'm going to change it to HTML table ID because that more correctly describes what is going to be inputted there, which is going to be a string. And then I'm going to take that ID and I'm going to get hold of the HTML table that I care about. So to do that, I'll let HTML table be the element with the specified ID. So I use get element by ID, and then I just pass in the HTML table ID. Next, I want to check that this element actually exists. So if HTML table doesn't exist, I want to raise a error. So table with ID, HTML table ID not found in the DOM. And if that's the case, we're going to return to end our function. Now, if the HTML table does exist, we want to insert the Apache arrow table into this HTML table. But first, we need to clear anything that's already in the table by accessing the inner HTML of this element and setting it to an empty string. Now we're going to create our first row. This is going to be the headers. We create an element of type tr, which is a table row. Then we take our HTML table, and the child that we're going to append is the table header row we've just defined. So now we have a header row, we need to insert each of our field names. So we need a for loop. So let's take our table schema, which is an array, and use the for each method, and then say for each table column we need to create a table header. So let table header equal document create element of type table header, set the inner text of our table header to be the table column, and then take our table header row and append each table header into that table header row. Now the next bit's going to be a bit trickier because it's going to involve nested for loops, because we're going to loop through each row, and then for each row we're going to loop through each element of that row. So for each table row we need to create HTML table row element, then we take our HTML table and append the table row element to that table. This means we have a table row in HTML which we can populate with our data. To access the data in our Apache arrow table rows, we need to use the field names for each column. So we need to start by iterating through the table schema again. So for each table column, we'd like to create a data cell in our table. So to do that, we use the HTML element td. So let td equal document.create element of type td. Let's change the inner text of that table data cell to be equal to the data from our Apache arrow table row at the correct column, and then let's append this data cell to our current row, and then let's just end our function there and test out uploading a table. So I'm just going to choose the cars parquet file again. I'm just going to set the table name to cars and hit create table, and I've hit an error processing file or querying data. Now what would be useful here is knowing what that error actually is. So I'm just going to add to this console log here the error itself, and I'm just going to try and recreate that error. So refresh, choose the cars parquet file, enter cars, hit create table, and now we can see the particular error. Con.query is not a function at update table list. So let's go to update table list, which is this function here. So what I need to do is just add an await before db connect, cars.parquet, cars, create table, and then this time we still have an error. So the error here says HTML table ID is not defined. So if we just go back to our code and go to HTML table ID, as you can see here, this one is uppercase D. So let's change that to lowercase d. So let's save that, refresh the web page, choose file, cars, let's call the table name cars. Table rows is not defined. So let's just find where I've used table rows. So table rows has been used once here, and that's because I've missed out defining the table rows. So I'm just going to define the table rows here. So I'm going to take the arrow table, and then using the arrow API, I'm just going to use the toArray method to return an array of the table rows. And I'm just going to create another console log just so that I can sense check this and make sure it looks okay. And this can be table rows like so, and then I'm just going to add the table rows constant in there as well. Refresh the page, choose File, Cars, Create Table. As you can see here, we've got a list of our registered tables. So we know now that we've got a table in our database called cars. So if I now choose a different file, so say I choose ducks.json and I call that table ducks and I hit create table, it now registers a second table in my database. The next thing we need to do is write a function for running the query. So async function run query. And the first thing we're going to do is get hold of our query input over here. So to do that, we're going to create a constant called query input, and we're going to go to the document, and the ID of that element is going to be query input. Query input isn't the ID of any element in the HTML document. So you need to go back to the HTML and you need to find this. Now the text area is this element here, and we want to give this element here the ID query input. So now we can get hold of that element and we can create a variable called query and let that be equal to the value of our text area, which is our query. The next element we want to get access to is the query results div. So let's define a constant called query results div. Let's go to the document, get element by ID, query results div. And then the first thing we want to do is take the query results div, and I want to access the style of that element, in particular the display, and I'd like to set that to block so that this div is visible. The next thing I want to access is the last query div, and I'm just going to set that to document get element by ID last query div, like so. I do not have an element with that ID, so I'm just going to go to the element that I'm talking about, which is this div here, and I'm just going to set the ID here to last query div, and now I can take that last query div and I can set the inner HTML to be equal to the query itself. The next two elements that I care about are the result table and the result error div. If the result produces an error, then I can populate this div here, and if it doesn't, then I can populate this table. So this is the result error div. So now I'm going to wrap the next part in a try, and I'm going to catch any errors with the following. Now, if running a query results in an error, I'd like to hide the result table. I'd also like to empty the result table element by taking the inner HTML and setting that to an empty string. Then I'd like to take the result error div and make sure that that's visible. And then I take the result error div and populate the inner HTML with the error. Then I also want to create a console error processing file or querying data, and then put the error itself on the end. Now we need to say, well, what happens if our query doesn't fail? Check that the database is still initialized. If it's not, we'll raise a console error. DuckDB Wasm is not initialized. We'll also return to exit the function. Next, we need to create our database connection, and we'd like a console log just saying that the database connection has been established. Next, we want to take the result of our query, and we use our arrow to HTML table function, and we pass the result into that function, which will then insert it into the result table HTML element. I'm also going to run update table list at this point, and now we just need to change what's visible in our HTML. So we take the query result div and we make that visible. We take the result table and make that visible, and then we also just make sure that the result error div is hidden. We also make sure that the result error div is empty, and then finally we take the database connection and close it. Just create a console log to say database connection closed. And then one last thing we need to do is add this function to the event listener. We also need to make sure that we end that function with a closing curly brace. We set onClick to be equal to the run query function. Now, if we just refresh the page, select all from ducks, hit run query, and there we go. Okay, so just using a HTML file and a JavaScript file, we've got a fully functioning database running in our browser, but it doesn't look very good. So we're just going to add some CSS to make things look a bit nicer. To do that, we just create a new file and call this styles.css. And we're just going to add a style sheet here, and we can close that tag there. So first of all, we're going to change the font across the whole web page. So to do that, we access the body element. I want all of the table information on the left-hand side in a column, and then I want all of the queries to exist on the right-hand side in a different column. But to do that, we need to create some HTML elements to represent those columns. So the first thing I need to do is put my entire page in a div, and I'm just going to indent everything else so it's easier to follow. And that div is going to be of class type container. Next, I'm going to split my page into two other divs. So I'm going to create another div here, and that's going to contain everything to do with uploading tables. And that div is going to be of class left column, and everything past that, which is to do with running queries, is going to be in another div. So I'm just going to create that div here now, and that div is going to be of class right column. So on the container class, the first thing I would like to do is change the display and the height. The next thing I'd like to do is take the left column class and set the flex, the max width, the padding, the background color, and then set a box shadow. Now let's change the right column class. We want to set the flex value and the padding. Now for our headers, we'd like to set the margin. Next, let's take the element with ID, create table div, set the margin bottom and the padding. This should be a div that's wrapped around anything to do with creating a table. So let's just add that in here, and let's set the ID to create table div. Next, let's take the tables table and the result table and set the width of those and the border collapse. Now let's set some CSS for the elements within each table. So we'd like to set the border. Next, we need to style the element where we write the query. This is called query input. We set the width of this, the margin bottom, the padding, the height, box sizing, resize. And finally, we want to style the query button. Now, the query button, we haven't given an ID. So what we want to do is we want to just go to this button here, set the ID to query button, access the element with ID query button. We just want to set the padding and the cursor. So now we have a fully functioning analytics database running inside our browser using just 3 files. That's without any web frameworks, any bundlers, any backend. So let's see what this looks like. So first I'm going to choose a file. I'm going to choose the ducks.json and I'm going to open it, and I'm going to call this table ducks. I'm going to create the table, and then I'm going to add another table. So I'm going to go to the cars parquet, and this time I'm going to call this cars, and I'm going to hit create table. And then now I'm going to test out a query. Select all from cars, and as you can see, we've got our cars table here. And then now I'm going to take the min of the miles per gallon, the max of the cylinders, and the average of the gears, just to see if that works. I'm going to hit run query, and there we go. So as you can see, this is an analytical database running in the browser. There's a link to the GitHub repo in the show notes. And if you like this video, make sure you subscribe, as there's more videos coming soon.